Ladies and gentlemen, welcome back to the core of everything. Today we are focusing on moons or natural satellites. NASA have reported that the solar system has about 293 moons, natural satellites, orbiting planets in our solar system. 5 for the dwarf planet Pluto, 16 for Neptune, 28 for Uranus, 146 for Saturn, 95 for Jupiter, 2 for Mars, and 1 for the Earth. It could be said actually the Earth has one moon, the moon, but actually every now and again it might have more than one moon because asteroids may come past Earth and get sucked into our orbit for months, maybe even years. But there is only one permanent moon, and that is obviously the moon. But as I say, there's 293 moons. And today we are going to focus on 2. So Mark has gone away and focused on Titan. And we welcome back onto the podcast Banusha Kugabalan.
Hey guys.
And you've gone away and tried to focus on Io.
Yeah.
And also we'd like to introduce a new segment at the end of the podcast.
Wow.
So Mark, let's kick things off with
Io. So Io was first discovered in 1610 by Galileo Galilei, and this is one of the moons of Jupiter, and there's a load of mythology that goes on in space and of the naming thing. So Io was the priestess of Zeus's wife Hera, and actually Zeus fell in love with Io, the priestess, so he turned her into a cow so that his secret love wouldn't be exposed to his wife Hera. Anyway, Banusha's been raving about this story she's got about Io for a while. So
you're mad about moons. You're a lunatic.
Good one.
Good. So, tell us about Io.
Yeah, as you said, Galileo Galilei, or the other way around. Is it Galileo?
Oh, I think it is. Yeah.
Galilei, isn't it? In 1610, he discovered all 4 Jovian moons. So Jovians are your gaseous planets, Saturn, Jupiter, Uranus, and Neptune. And he discovered Io one night, but he was actually confused whether he discovered Io or Europa because they're so close to each other in orbit. And the next night he actually discovered it was Io.
What a run.
And yeah, all in
2 moons in 2 nights.
I know. And then discovered the others the same week.
And then discovered our moon the next day. Yeah. He ignored the big thing in the sky.
It's like a bright light in the way.
Well, Io was the first moon he discovered after our own moon. And from this, Kepler's laws were also confirmed because around the same time, Kepler was trying to understand planetary motion around the focus, which was the sun.
So, sorry, Kepler focused on orbital dynamics.
Yeah, so there are 3 laws that he came up with. First one is that all planets have an elliptic orbit around the sun, which is the focus.
So that means it's not a circle, it's kind of squashed a bit.
Yeah,
right?
so it's like an egg shaped. And the second law is that when a planet is in orbit, the amount of area it sweeps through is equal to the same amount of time, no matter where it is in the orbit.
So if you've got like a pie, and if you're really far out on the pie and you make yourself a slice, the size of that slice has to be the same as if you're really close into the centre of the pie and you make yourself a slice. Obviously, the circumference of your slice needs to be bigger to be the same area, which basically means that the further out you go, the faster your object needs to be moving.
Yeah.
Right.
And so the third law is that the orbital period of the planet is directly proportional to the distance between the sun and the planet.
Okay. And the orbital period is the time it takes to go round the sun, for example.
Yeah. Yeah, so Kepler's laws were defined and confirmed when these moons were discovered. And then the biggest discovery was the speed of light, because back in those days, people thought that speed of light was an instantaneous, there was no value, it was infinite. But Romer, he's a Danish astronomer, whilst he was working in the Royal Observatory in Paris, he was looking at these 4 Jovian moons, and he was specifically looking at Io and looking at the orbital time period over several years. And it takes 1.7 Earth days for Io to orbit Jupiter from Earth. And what he noticed was when Earth is close to Jupiter, Io's eclipse behind Jupiter was about 11 minutes earlier, whereas when Earth was further away from Jupiter, the eclipse was 11 minutes delayed.
So what we've got going on here is, imagine the big map of the solar system, and in one scenario you've got all the planets orbiting, and you've got Jupiter and the Earth across over one side together, and he's observing when Io disappears behind Jupiter. Yeah. Is that right? And then that's happening quicker than if you've got the Earth on one side of the sun and Jupiter on the other side of the sun, and then Io goes behind Jupiter. And because he's looking at it from so much farther away, for some reason that you're about to tell us, I imagine, that's taking a bit longer. Yeah.
And he thought that if there's that time interval and there's a delay and it starts early, he knew the orbital time, he calculated it all. So
and
it
that's
didn't make
fixed,
sense.
Isn't it?
Yeah, it's
wherever
fixed.
Jupiter is in the solar system, that's the same.
It's always going to be the same. So he knew that. He had the calculation. So the only reason he could think of was that speed, light must have a speed, and it's not infinite or instantaneous.
So he essentially used the time difference with the distance between Earth and Jupiter to calculate the speed of light.
Yeah, very impressive.
What is the speed of light?
3 times 10 to the 8 meters per second, I think, or it's 2.998. But I guess maybe even just back to basics, that this also tells us that light isn't just all pervasive. It travels in these little packets that I think Einstein eventually discovered called photons.
Yeah.
Right, so that actually these little packets of light are flying across the solar system, and that takes time for them to travel. Yeah. They're going super fast. I think it takes about 8 minutes to get from the sun to the Earth. Is that right?
It does, yeah.
So if the sun went supernova or exploded or something, we'd have 8 minutes to
scream.
Well,
I guess we wouldn't see it, would we?
Yeah, we wouldn't know.
We could scream anyway. Yeah. But, so let's hear about Io. What's its composition? Why is it interesting to us?
Yeah, so Io is the most geologically active place in the solar system. It's hugely volcanic to the extent that you can see volcanoes exploding out into space from spacecraft that we have sent to Jupiter. Miles and miles up into its very thin atmosphere. And it's got an atmosphere of sulfur dioxide. It's got lots of molten sulfur on the surface, but it also does have ice fields. So even though it has these kind of volcanism, it gets very cold. It gets down to minus 130 degrees Celsius. So very, very cold. But one of the interesting things about Io is that it has this crazy tidal heating effect that makes it so volcanic. So as Banusha said, one of Kepler's laws is that these objects in the solar system have eccentric orbits, so kind of flattened circles, basically, as they go around their host planets. So Io's there orbiting Jupiter in an eccentric orbit, but it's also being pulled around by Jupiter and the other moons, Europa and Ganymede, some of the larger ones. They're pulling it into a different shape. So Io isn't always a round kind of object, not a sphere. It can be pulled into an egg shape. So you've got this interaction of, as it orbits Jupiter, it's going from a round shape to an egg shape, and then that's changing in its time, I guess the 1.7 Earth days it takes for it to get around Jupiter. And that causes a vertical change in Io's surface of about 100 meters, which doesn't sound like much, but you have to think about the friction that's going on within Io's surface, under the surface, creates a huge amount of heating that is kind of generates this furnace within Io, creating volcanism. So on the Earth is heated by primordial heat. So these are radiogenic isotopes decaying, producing heat. On Io, the heat flow is about 20 times more than Earth, which is why it has this volcanism.
But this is a much more physical process where you've got this tug of war effect between those moons and Jupiter itself. That's push and pulling this planet apart. And I assume the composition, because the atmosphere, you said, was sulfur dioxide rich, whereas ours is nitrogen and stuff. Yeah. But our volcanoes, when they erupt, it's typically rich in silica, iron, nickel. But I assume, therefore, that these volcanic eruptions are rich in other things, like sulfur dioxide.
Yeah, lots and lots of volatiles. It will... my understanding is that Io is also a silicate body, so it will be erupting silicates as well, and other kind of rocky materials, but it is just hugely kind of gaseous eruptions.
I've got a question. So, on Earth, you have tectonic plates, boundaries and stuff, and that's what causes eruptions. You don't have that on Io, and what causes that?
Yeah, that's a really good question. So Earth is the only place in our solar system, or only place, I guess, in the universe that we know of at the moment that has tectonic activity. So it's really unique in terms of having plates. So I guess what's going on Io is you've got probably hot spots coming up, and just all this heat is trying to escape from the surface, and it finds weaker points within that crust where it just eventually has to break through by pressure from the magma and pressure from all these gases that are stored up.
I'd also wager that the mantle itself is probably slightly different in density composition, and the lithosphere, the crust on top of the mantle in Io, might be thinner. I have no idea, but I'm sure there's other things at play rather than just anomalous zones of hot magma rising through.
Good question.
There's also Io passing around Jupiter creates a sort of electrical charge that results in Io contributing to lightning strikes on Jupiter.
Yeah, so when Io is orbiting, because I think it orbits around 422,000 kilometers away from Jupiter, so it's very close. And Jupiter has a massive magnetosphere. It extends like 7 million kilometers towards the sun, and then nearly in the opposite direction, it goes near towards Saturn's orbit. And whilst Io is orbiting through the magnetic field of Jupiter, a voltage and current is induced, and this comes down to just laws of electromagnetism. And the current that it produces chooses the least resistive path, and then it goes into the upper atmosphere of Jupiter and creates lightning effects.
And the voltages and current, so the voltage is around 400,000 volts that is being generated here in about 3 million
What's
amps.
a plug socket normally? How many volts in a plug?
240,
okay,
I think.
Okay.
So it's huge amounts of electrical energy that then gets, as you were saying, gets channeled into Jupiter's upper atmosphere, creates lightning strikes, and also aurora.
Yeah, so it can also create like a plasma effect with like a donut-shaped plasma between Io and Jupiter's magnetosphere, and it creates auroras.
Like the aurora borealis.
Yeah,
exactly.
Northern Lights. I bet that looks quite striking.
Yeah, you can actually Google images of it, and you can see it at Jupiter's north pole, I think.
Really? So let's move on to Titan.
Yeah, so Titan is one of Saturn's moons. It was discovered in 1655 by Christian Huygens, who was a Dutch astronomer, and it's named after the Titans were the Greek gods before the Olympians, so Zeus and all them lot who lived up on Mount Olympus. Titan is tidally locked with Saturn, which is a bit like our moon. The same face always points towards Saturn. So Titan, we know stuff about Titan because it was mapped by the Cassini spacecraft, which did 120 flybys of Titan between 2004 and 2017 using radar, a type of radar called synthetic aperture radar. And the reason this is really helpful is because Titan has a very thick atmosphere, and radar can penetrate through the atmosphere and allow you to see what's going on the ground. And there was a paper published by Lopez et al. In 2020 in Nature Astronomy, which produced the first geomorphologic map of Titan, a global map, and they divided it into 6 different units. So they had plains, they had dunes, hummocky terrain, lakes, labyrinth terrain, and craters. But the really cool thing about Titan is that it's got these huge lakes that in radar images look very kind of black because the radar just bounces off those surfaces. And these are lakes not of water, but of methane and maybe some ethane as well.
So if I was to sit on a deck chair on Titan and just look at the rain and look at the lakes, what would that actually look like?
So you would see, methane is a colourless liquid, so it would just look kind of, the lakes would look colourless, but the atmosphere would have kind of a greenish bit of a greenish haze because of that methane. And actually, you would feel a bit under pressure, even if you were sitting on your deck chair, because the atmosphere is a little bit thicker than the Earth, so you'd be under, it's about 1.6 times Earth's atmosphere, I think. So it'd
feel like you're very deep underwater.
Yeah.
But you're on the surface.
Yeah.
Very dry.
Yeah.
All covered in methane.
Yeah. But these lakes are super interesting because we have observed magic islands, right? So the lakes on Titan are named after mythological creatures. So we've got the Kraken Sea, for example, which I love. And we've also got the Ligeia Mare. Ligeia was one of the Greek sirens, the people who would sing, and the boatsmen would get drawn in by their beauty and their singing. You know that? No.
Yeah.
So in 2013, they imaged these lakes and they were radar dark. So they had very dark colours because basically the way the radar works is it shines a light on your surface. If the surface is very flat, that light just bounces off and goes elsewhere and it doesn't go back to your detector, so you don't get a signal. So it appears very dark. So these seas were flat and devoid of any features. That was in 2013 when Cassini did its flyby. In 2014... when they re-imaged the same area, they found that there were these bright spots in radar images that were transient and lasted hours to weeks within the lakes. And some work's been done on this, particularly by Xinting Yu and colleagues, and this was published actually just in January 2024, so very recently in Geophysical Research Letters. And they suggested that these transient bright spots are floating chunks of glacier-like snow. Not water snow, but actually organics. So nitriles, benzene, hydrocarbons, things made of carbon, hydrogen.
But organics doesn't mean life.
Yeah.
It just means compounds like
these kind of compounds, yeah. And so what's going on is in Titan's atmosphere, you've got methane and nitrogen and simple gas molecules being converted into organic compounds by photochemistry. So this is just reactions kind of helped along by light from the sun. And these organic molecules, they fall like snow, and then they clump together and they carve like a glacier. So they kind of come off the surface and they float off into the sea, and they float because they're very porous, because they're these like kind of fluffy clumps of snow. A bit like a Swiss cheese. So they've got loads of holes in them, or honeycomb, they've got loads of holes in them, which means that eventually they'll take on lots of liquid methane and sink, which is why they're transient.
Wow. So if there's water and like carbon, all these organic compounds, is it like a habitable environment, or like?
Yeah, so this is actually a really interesting question. So normally for habitability, we're looking for liquid water. So we've got liquid methane, and we think that under the crust, under the surface of Titan, that there might be water ice. So somehow we need to heat up Titan to liberate that water, that water from the ice. So how are we going to heat Titan up? What's going to happen in the future?
Or is this like one of those lateral thinking questions where we have to it's like an interview question?
What could happen in 6 billion years that could heat up outer parts of the solar system?
Come on, class. Banusha?
Life cycles of stars.
I mean, our star will probably die soon.
Yeah.
Not soon, but
6 billion years.
Yeah, 6 billion years.
And what happens when our star dies?
It explodes.
It explodes. So it goes through the red dwarf stage, where it expands. It goes through this really unstable stage where it expands and a lot of material is kind of thrown out into the solar system. But that might mean at that time that Titan becomes warm enough to support stable oceans. And it's already got all these organics. And we know this from the radar data. And we've seen like kind of river processes and rain processes on Titan. So, it's got all the makings of a promising place. And actually, we're going to visit it, right, Banusha?
Yeah, so NASA and ESA have plans to visit Titan from the Dragonfly mission in 2026. It's planned to launch, and it'll arrive at Titan on 2034.
Wow, 8 years.
Yeah, and
Dragonfly's pretty cool, right? Because it's this quadricopter.
Yeah.
So it's like a bit like a drone. It's got kind of 4 rotors.
Yeah, and the plan is to look at the origin of Titan, because it's quite poorly understood how it was formed. Mm-hmm. And there's theories that it was formed when our sun was formed in the protosolar disk, and whereas Saturn was formed well later.
Oh, really? So Titan was formed before Saturn?
Yeah, that's what they think from looking at the nitrogen content in the atmosphere and looking at the building blocks of the moon and stuff. The organic compounds that are found on Titan, it's very similar to early Earth, and they're exploring how, if they can understand Titan now, it can help us understand how our planet was formed as well, in the early days.
And the birth of life. Bill Bryson puts it in one of his books. He says that there could be life on other planets, but we won't be able to detect them because they're far beyond what we conceive life to be. It's not that our Earth is the only thing that's habitable. It's that it's the only thing that's habitable for us.
Yeah, so there's this idea that, because our life is carbon-based, but there's an idea that other life could be like silicon-based, for example. And that's just quite hard for us to get our heads around.
And speaking of Bill Bryson, it comes on to our newest segment of the podcast, and it's called What in the World? So,
tell us about this segment.
So, we're going to introduce a new segment where we choose a topic or a special story or anything in pop culture, whatever it is, but it has to be rock related.
What have you got for us today?
Today, we'll focus on Guillaume Le Gentil. Now, when I say a segue from Bill Bryson, I read this in one of Bill Bryson's books. I think it was didn't he write like Brief History of Everything or Time or
oh, no, that was
Hawking and Bryson wrote. They both have books that would have a similar title. It's like the Brief History of Everything or something.
Yeah, and the Brief History of Time,
something like that. So today we focused on Guillaume Le Gentil. He's French. Guillaume Le Gentil, if you translate it to English, is William the Kind.
Oh.
So he's a modest chap.
Oh.
But I will say, what a stoic man. Now, he was a stoic man.
Bill Bryson.
I'm sure he is. But Guillaume Le Gentil really is. So he was a French astronomer from the 18th century. And he discovered several solar nebulae. He was part of the Royal Academy of Sciences, which is quite prestigious.
Big cheese.
Big cheese. Big fromage, as the French, as he would say, as William the Kind would say. And he did a lot of work on the Venusian transit. So Venusian
transit.
Yeah, no, I was like, iconic.
Is it Venetian or Venusian transit?
Venetian would be of Venice.
Yes, okay. Venusian transit. And that occurs when planet Venus, it travels between the sun and a superior planet, which is a planet that orbits the other side of Venus to the sun. So
further
out. So when Venus passes over the sun, it's not like a solar eclipse with the moon where everything gets put into shade and it covers the sun. This is a tiny dot that travels.
Kind of dark dot across.
Yeah, so you wouldn't get really a shadow. You'd more get like a little spot on your forehead. Do you know what I mean? If you just see it travel slowly across your forehead.
Yeah. Do you think that must actually... No, the light will bend round Venus. Imagine if there was just like one dot and there would be like shadow chasers. You know, like you've got hurricane or tornado chasers. You have shadow chasers trying to find that.
It's quite slow. Oh, I see what you mean. I thought you're chasing after the dot.
Yeah, just trying to find where that little dot is.
It'd be amazing, wouldn't it?
Yeah.
I can't imagine.
No, the light must bend around. Yeah, okay.
Too small. But it's quite rare. So it happens, a pair of transits are 8 years apart, which is followed by a gap of 121.5 years and 105.5 years.
Right. So big gaps between
So you've got two within 8 years and then big gaps.
Right, okay.
121.5 and then 105.5 years. So the most recent one was the 5th and 6th of June 2012. And before then it was the 8th of June 2004. But the next one isn't until December 2117.
Oh, missed it.
So I do think I remember the 2012 one.
Really?
Yeah.
Did you outside or did you saw it on the news?
I think we got
come and look at this sun.
I can't remember if the solar eclipse that we were looking at all like that.
There was a solar eclipse in 20...
Was it 2017?
2015. So, dear old Guillaume. So, he worked in France and he was studying the Venusian transit. And the transit was coming up in 1761. And he thought where to see it best. So, he thought, and the clearest view. So, he thought Pondicherry in India.
Of course, that's my go-to.
yeah, exactly.
Do you know
I know that place.
Oh, really?
Yeah.
Is that in the foothills of the Himalayas or is it the Himalayas?
No, it's south.
Okay.
Near like the Tamil states, I think.
Well, okay. Well, I don't know why Pondicherry was so great, but he left France 1760, so he had a year to get there. On the order of the King of France, Louis the 15th. Yeah, Louis the 15th.
Say Louis and you're probably right.
Yeah. So he arrived in the Isle of France, Mauritius, and realised the 7 Years' War between France and Britain had broken out, which prevented any travel east. He soldiered on and was still due to get to India before the Venusian transit when strong winds blew his ship off course, and he spent 5 weeks wandering about the Indian Ocean. By the time the transit came, the skies were clear, but he was still on his boat in the Indian Ocean.
Oh no.
And he tried to take these astronomical observations, but obviously the boat was rocking to and fro, and so he couldn't quite reach it, which is horrendous.
Yeah.
But he'd come this far. The next one was 8 years away. So he soldiered on, okay?
Reset, go again.
Packed up his stuff.
Build back
right,
better.
Yeah, exactly. Huge push for 8 years' time back in India. Along the way, he made other astronomical observations, studied Indian astronomy, and the day comes, 4th of June, 1769. It's been 9 years, roughly, since he set off from France. He gets up, it's a lovely day. I mean, it's so nice. You know, clear skies, he's thinking, I can't be my luck here.
Couldn't ask for a dreamier day.
Couldn't believe it.
About to go down in history.
Yeah. Checks everything is in order. He climbs up to a nearby viewing platform. He sets up the telescope. And just as Venus starts to move across the sun, a single cloud floats in front of the sun for the entire duration of the Venusian transit, which is 3 hours, 14 minutes
I'm devastated.
and 7 seconds. And just as it was over, the cloud parted, and it was a lovely day.
No.
But that's not all.
Oh, no, don't.
So rather stoically, again, he packs up his instruments and he heads to the nearest port to go home. Right? On the way home, he catches dysentery, which is a horrendous infectious disease
Poor guy.
which causes inflammation in the intestines. And he spent a year in bed. He then crawled onto a ship to cross back towards Western Europe, where he got hit by a hurricane.
No.
He got hit by a hurricane.
I don't like where this is going.
Broken. He finally makes it back to his home. 11 years away, having achieved nothing. Only to find that he'd been declared legally dead. His wife had remarried, and all his relatives had plundered his estate.
What the hell?
And that is the story of Guillaume Le Gentil.
But I did not expect that to go that way.
Wow.
And I mean, there's a happy ending after lengthy litigation and some recommendations from the king, one of the Louis. He recovered his seat in the Royal Academy of Sciences, which he was removed from when he was legally declared as dead, and he remarried. And actually, there's been a book. I don't know. This isn't a love story. It's not a rom-com. But someone's written. Antoine Lorraine has written a book about Guillaume Le Gentil called "An Astronomer in Love." I can't see the love story.
Yeah. Well, it's a love story with Venus.
Astronomy.
And Venus was the goddess of fertility, I think, right?
That's it.
It's a metaphor.
Always the lover, always evading the...
Unrequited.
Yeah. Single cloud.
It's ironic he suffered the Venusian transit, but he was always in transit in a way, wasn't he?
Yeah.
Every cloud doesn't have a silver line.
Thanks, Jack. Great story.
I think so.
No, it was really good. I'm devastated, though. I thought it was a happy ending, and it wasn't.
Can you give us a happy ending? Have you got any good facts to share? Have you actually seen Io through a telescope?
No, I couldn't see it.
Right.
I seen Orion's Nebula, which was
cool.
incredible.
Yeah.
And the moon.
Wow.
Our moon.
If you've got any astrophotography pictures or pictures of the moon, please do send them in to us. You can get in touch on Twitter and Instagram or any other way that you can find us. Please do send them in. We'd love to see them.
If you're moon crazy, if you're a lunatic. I will say, I actually have the fact here. So a lunatic stems from the word luna, which is moon in Latin, and the Roman goddess of the moon, Luna. And it basically stems from someone being moon crazy or moon mad, where people were affected by changes in the moon.
Right, okay.
But actually...
That's really interesting.
Yeah.
But like werewolves?
I don't know if werewolves exist.
Yes, do they not? Are you messing?
You could be a Jovatic if you're affected by Jupiter. Here we go.
Is that true?
No, but
Jovian
it could be, right? Jovian?
Lunatic, Jovian tick.
And
I'm trying to think of a really funny one at the end.
So while Jack tries to get the last word, thank you so much for listening to our episode today, and we'll talk to you soon.
Thanks.
Bye.
Bye.
Bye.